In this lecture we are going to learn about STL, okay, so that is Standard Template Library. Here you will learn about vectors. So first, before going that, we will learn a little bit about what are STL in C++. So STL stands for the Standard Template Library, which means that your C++ provides you libraries for representing different data structures, and these data structures are generic. So what does it mean? So similar to your templates, so when you define, let's say, a linked list, a list, or a vector, or an array, okay, so you can have these data structures use templates, which mean you can have a list of integers, a queue of integers, a queue of string objects, a queue of characters, queue of doubles, anything, okay. So this way it helps you that you don't have to write your own data structures implementation, and they are generic in the sense that these data structures, like for list, it can hold your ints, doubles, etc. okay. So this is the benefit, and now here we will see our first standard template library that represents a vector, okay. So vector is a kind of a dynamic array, okay, where you can have access the elements directly, okay, using index. So vector, if we have, so it's similar to array, but it's dynamic in the sense that you don't need to define the length of that array. If you have increased the size, it will increase automatically, and it is dynamic. The size is dynamic. So what are good things about a vector? The thing is that you can access is very efficient, okay. So in vectors, access is very efficient. I can access the 6th element, 10th element, or 99th element, any one, just by having the index I, okay. So vector, if we have vec.at I can access directly, or even in fact vector I, that element, ith element, I can access. So this is good about vector. What is not good about vector is that if you do insertion at the end or in the beginning, it is fine, but if you do insert in the middle somewhere, okay, or at some random place, and even if you delete at some random place, it will become very costly affair, okay, because you have to shift. So for example, if this is the array, I have 1 2 3 5 7. Now if you ask me to insert a 4 between 3 and 5, so this is an array and these memory locations are contiguous. So what we need to do is we need to shift everything after 3. So 1 and 2 will remain there, but 3 will come here, 5 will come here, 7 will come into a new place, and then only, okay, in fact 3 will be here, so 3 will not be shifted, 5 and 7 will be shifted, and an empty space is created here where you insert a 4. So this will basically have a O of n, where n is your size of integer time complexity in the worst case. And similarly for delete, if you delete somewhere here, then you have to do a left shift. So this is the case, and now what we want is that we want to look at how we implement a vector. So let's see the code. So again, you need to include #include vector, okay. So this is the class name. If you include this one and using namespace standard, so that you don't need to write always standard. So we define a vector. So in fact I have done this one standard vector you can take. So this standard vector means I'm taking this class from standard namespace. Standard vector, then you have, because this is a generic template class, you have to tell that, okay, I'm having a vector of int type, and then I will give my name, my vector. So this is done. Then what happens, you have a lot of APIs for this they provide, okay. So this is the data structure, and for data structures, you know, they provide a lot of APIs. So first one is my vector dot empty. Has it got any element in it? So if I check my vector, is it empty? So just use the function my vector dot empty. It will tell you, it will return true if it is empty, and it will return false if it is not empty. Now to insert, what happens? I just do push back. So push back is a function that will push an element at the back of your array. Okay, so back of the array, push back, I is 1, so 1 is pushed here, then push back again 2, and then 3, then 4, and then 5. So 5 things are inserted because we are doing pushback. So 5 will be at the end, 1 will be at the beginning because 1 was inserted first. Now if you check, next function is, so my vector dot size. So size, what it helps in, now I have 5 elements, so my vector dot size. So this will return you the size of the vector. So now 5 elements are here, it will return us 5. Again we want to push back a few things, so we push back 6 to 10. So 6, 7, 8, 9 and 10 are inserted in our vector. So this is done. So push back, now you know APIs, some of the basic APIs, push back. Okay, then you can also do push underscore front. So it means you can push something in the front. So if I do something like here, after this one, if I do my vector dot push underscore front and then 11, so it will be inserted now here. Okay, and then you push back my vector dot push underscore front 12, so 12 will come here. So something like this will happen. So these APIs are provided to help you concentrate on your logic rather than just write your own APIs, check for their bugs and so on. Okay, so again, now after that we can check what is our vector. Is it empty? Of course it will not be empty now. Then a few more important things. I need to iterate through the vector, isn't it? Like an array, I need to iterate through the vector, that okay, I want to access the first element, second element, like that till the end. Then you are provided with iterator. Okay, iterator. So here is this iterator. How you write iterator? So we will have standard vector. So this is the thing, data structure or standard template for which we want the iterator. Standard vector int, I want an iterator for this one, so I will write iterator. So iterator will be given for this. This is how we write, and this is equal to my vector dot begin. So what will happen? Now you will get an iterator for your beginning of that array. Okay, so let's say it was just 1 to 5, 3, 4 and 5. So you will get an iterator which is pointing out here. So this is the case, and what are the things we need to define for your iterator? We need to tell it that it is an iterator of type vector. Then again in vector also it is of type int, so that when it is iterating, it knows how many memory location it has to escape to go to the next one. If it is integer, it might be 4 bytes. If it is a double, it might be 8 bytes, so that iterator will shift or jump by 8 bytes. Okay, so this is, I give you the size to the iterator, and then I point it to the beginning of that vector. Then what I do, iterator, I will tell it that till it is not equal to the vector, my vector dot end. So here again you can see these are the pointers that are given for the vector. My vector dot begin, it will give you the beginning of the vector.